Okay folks, second video for the morning. We've got 3 and that will be all of the videos for the day for learning, and then all we're going to do is we're going to try and take the day to put this stuff together. This is called Ionic Structures, and there's 3 parts to the naming, so you got to keep your head in the game. You got to watch these videos a couple of times and you've got to make out rule sheets. This is going to be all open book when you get tested on this. These are called simple ionic. It's when they start with group 1 or 2 metals or aluminum. So this first type starts with group 1 or 2 or aluminum. Aluminum's the exception here. When you name these, you don't use any monodies or tris. You just name what you see. It's calcium and it's chlorine. Remember, we always take the second part off and put IDE on the ending. So it's calcium chloride. Once again, we ignore the prefixes or the numbers, the subscripts or the numbers that are down here. This is sodium oxide. Now, here's where it gets a little trickier. It's with the formulas. Step 1 is to put the elements down. So let's go Mg and I, Al and Cl, Ca and O. Step 2, once you've done that, you come here and we're going to look for things called crossover numbers. So on a periodic table, you've got to indicate these are called crossover numbers. 1, 2, 3, 4, 3, 2, 1. So you write them above the columns. Column 1, 2, 3, 4, and then for columns 5, 6, and 7, it's 3, 2, 1. And you write the crossover numbers above the element. So if you look on the list, Mg has a crossover number of 2. Iodine has a crossover number of 1. We switch partners, Mgi2. Aluminum has a crossover number of 3. Chlorine has a crossover number of 1. AlCl3. Now, where did the 1 go? In chemistry, we often don't write the 1s down. So when we do crossover numbers, if something is a 1, don't write it down. Calcium oxide, Ca2O2. I'm just going to show those crossover numbers one more time. Calcium, 2. Oxygen, 2, cross them over. Now, this would be Ca2O2, and I'll mark that right if you do that on a test, but you can cross out these crossover numbers because they're the same. So this is how it would read if you were actually doing this. It would be CaO. What makes these ionic? Well, you know when you use this, because we always start with a metal. Once again, where do we find the metals on the periodic table? The metals are to the left of the step ladder. We're usually using group 1 and 2 for this type, and aluminum. These are called simple ionic. The other ones we did had 2 nonmetals in them. Now what we're doing is the exact same thing, except for we got these odd looking characters that look like this. They're in brackets. And we call those polyatomics, which means many atoms. So many atoms coming together. I am going to send you a list of polyatomics. The only ones that you're responsible for are ammonium, carbonate, hydroxide, nitrate. Oh, I've got nitrate twice here. I don't know how that happened. Sulfate and phosphate. Those are the ones that you're going to be responsible ones. So I put a dot beside those. So when you get this, you can circle these. Let's take a look at these. So you'll notice that it's a grouping of elements, and I will put them in brackets. So the ATE ending in phosphate means many oxygens attached to a phosphorus. The crossover number for these is not found on the periodic table because these aren't elements, they're grouping of elements, so the charge is the crossover number. So for example, beside the phosphate, you'll see the 3-. So the crossover number is 3. We ignore the charge and we just put the number down. This here is 1. So there's a 1 minus there. They don't write the 1 in, but it is a 1 minus. So that's the crossover number. So let's take a look at this. We have calcium and we have phosphate. We said when we're naming these things, if they begin with a group 1 or 2 element, we said that we just name it. We ignore all the numbers in here. Sodium nitrate. So you just name it. That's your rule for naming. If you're naming simple ionics or you're naming these polyatomic ionics, then just name it. Now, for the formulas, you do the crossover numbers. So it's Na. If we go to the sheet, we will see that sulfate is SO4. We would notice that the charge on sulfate is 2, which is its crossover number. It's 2 minus, but we leave that part off. We leave the charge part off. And 1, cross it over, Na2SO4. Ammonium oxide. Ammonium is a polyatomic. It's NH4 and O. Crossover number 1 and 2. NH4 ammonium carbonate, NH4, CO3. This one's 2 polyatomics together, 1 and 2. Folks, you're going to have to make up a cheat sheet with all this information on it, maybe a couple of examples, annotate it, which means write a little bit about it. But we've got one more type of naming left to do, and then we're going to put it all together. So it's your job to watch these videos a few times to help you figure things out.